Hi, I'm Paul Goodman-Simpson from eRDS and welcome to this video. Today I'd like to show you how we create a building asset database in the cloud using information from a Revit model. The objective is to start to construct a detailed building database which contains all the rooms within the building and the spaces external to it. The database will be populated with fittings from the architectural model and mechanical components from Revit MEP. And this will be the first step in the process of constructing an asset information model. I expect most people watching will recognize this model. The only difference between it and the one you would download from Autodesk is that we have defined a number of rooms outside the building using room separators. This has been done so we can include the assets located in these spaces, which are often overlooked yet important from an FM and operations perspective. Each space has been given a tag denoting the room name and number, so later on we can pick up and identify assets modelled within the space and provide a placeholder for assets that we would define as information in the eRDS database. To extract a list of all rooms and their properties from the model, we will use the eRDS Manager plugin for Revit that is available from our website. It provides several functions to automate the process of extracting asset information from the model into an Excel file that will be used to populate eRDS Cloud. The first step is to obtain a list of rooms from the model by clicking on the orange Revit Room List icon. The manager will analyse the model and identify all rooms and spaces inside and outside the building. It loads them into a preview screen so we can check the information looks correct and provide the location where we want the output file to be saved. Clicking Export Data will create the file. When we open it, you will see a list of rooms together with their GUIDs for the spaces created by Revit and the FM Placeholders created by eRDS. The system will pull out all available information for room designations, their relevant dimensions and sizes, and any additional information that might be available. Before we continue, let's take a quick look at the FM Placeholders created by eRDS Manager. These are intelligent objects that take on the room name and numbers from the floor plans. By default, they are 10mm thick, positioned 10mm above the floor slab to prevent colour bleeding, and are coloured grey. Colour can be added to these objects using the FM Placeholder plugin for Revit, which is also available from the eRDS website. By applying colours to the various room types and spaces, we get a much improved impression of the site and how it works, which will hopefully result in a better understanding and communication of intent. We will look at this process in more detail in another video at another time. The second step in the process is to identify the assets that will become part of the database. This is done using the Asset Exporter option from the eRDS Manager. When opened, it shows us a list of types and families in the model, and it's up to us to decide what is and what is not an asset. This can vary from project to project, but mostly common sense will prevail. So for example, we are not interested in columns and beams for our processes, but we are interested in windows, doors, and all maintainable assets on the mechanical and electrical systems. There is an option to have the assets combined as totals rather than to have them listed individually. If you plan to deliver COBie, incorporate an asset coding protocol, or if the information is destined for an FM or CMMS system, then we want the assets listed individually. But if not, we might well decide that a simple total of asset by type is enough. Clicking Export will create the file we need to populate the asset database. It contains all the information required, including the asset type and GUID, plus their physical location in the building by level and room number. Notice that the assets have been separated onto two tabs in the Excel sheet. The Fittings tab will contain information from the architectural model, such as windows and doors, whilst the ME Comps tab will include all of the assets from the MEP model. Now we have extracted the information needed for the asset database, it's time to set up the eRDS Cloud project. So here I'm logging on to a workspace in eRDS as the administrator. There are no projects in this area yet, so we will create a new one using the Import from Revit option. We give the project a name, in this case Revit Demo Project, and navigate to the Revit Room List file we just created and click Import. It takes about 30 seconds for eRDS to create a SQL database in the cloud workspace, and once that's done we can enter the project. The database is structured in accordance with the COBie schema, and if we look at the project schematic we can see one location, 4 levels, 1 zone and 200 rooms. The next step is to populate the database with assets from the model identified by the asset exporter. There are several methods of importing data from various sources, but in this case we will use the Import Revit MEP option and navigate to the file we created earlier. We click Import and let eRDS process the file. eRDS uses the file to populate the library with assets from the model before allocating them to the correct rooms. In the library, we can see the import file created 2 fitting classes with 12 fitting types and 12 ME groups with 73 different component types. Now we have set up the project and populated it with information from Revit, we can take a closer look at the building database. Navigation around the system is easy to understand. You can do this by level, zone, room name or number, or groups of room of a similar type, as you see here. The idea has been to make the UI as simple as possible for non-technical people. If we navigate to one of the room types, we see a list of rooms in that class, and by selecting one of them we can see the information specific to that room. Since this project has just been set up, it will only contain the information available from the Revit model. In the ME Comps tab, we see there are 8 air terminals, 8 power sockets, 6 lights and a PIR. In the Fittings tab, we see the 2 doors into the room, but nothing else. Clearly, there is a lot more work to do. There are 4 key sets of information for each room that are needed for a true asset information model. In the Finishes tab, we should find information for the various wall, ceilings and floor finishes for the room. But currently, there is no information in the database because this information was not contained in the model. The ME Spec tab is where we will define the specifications for the mechanical and electrical systems for the room. At this time there is no information because it's yet to be added, but here is a glimpse of what we can expect once that's done. We will show you how this is completed in another video. At this stage in the process, the database has only been populated with the available information from Revit. Obviously, there is still more to do if we intend to furnish the owner-operator with a comprehensive information resource. Additional information will in time be added to these various tabs for each room. It should take less than an hour to set up and populate an eRDS cloud project with the relevant building information from a BIM model, but this is just the starting point. With a model such as the one used in our example, we probably have less than 30% of the total building assets that will be needed to support or run an efficient FM process and to create a true asset information model. Here we can see the kind of information that's required for a true building asset database. In our example, we have been able to use the MEP model to identify some but not all of the mechanical and electrical equipment, some of the maintainable assets on the HVAC system, most of the lighting components and some of the sanitary and power assets. From the architectural model, we can have more confidence that the doors and windows are correct in terms of numbers, types and their locations, and they are ready to be enriched with more complete asset information that will be required for FM. But as we see here, there is still a lot more to do to define and allocate approximately 70% of building assets that were not modelled as objects in Revit. We will show how this can be done in another video which we will post soon. In the meantime, thanks for watching, and if you'd like to know more about our solution for building asset databases, please visit our website erds.co.uk.